In this presentation, we're going to talk about attributes data collection and analysis, but we're also going to talk about the unique challenges specific to the medical device and pharmaceutical communities. Those challenges revolve around the FDA's 21 CFR Part 11 requirements, which are very stringent requirements in regards to electronic signatures. The situation we're dealing with here is we're a medical device organization that manufactures these injection pens. Now, we manufacture the product, we assemble the product, and then once these products have been completed, we do a final visual inspection to make certain that they meet our stringent quality standards. And what you're seeing here is a great example of one of our injection pens. Now, we manufacture lots of these different injection pens. And what we're doing here is we're talking about simulating a situation where it's quite complex. We have a roving inspector with a tablet computer that's communicating wirelessly to the InfinityQS database. And this roving inspector has to be able to select different product codes from different medical production lines as he or she is roving around the plant. Now, what we're going to do here is we're going to talk about really two different scenarios. One is that inspector and how he or she is interacting with the software. And then secondly, once we're finished with that discussion, we're going to talk about how a quality professional would go into the software and interrogate the data to extract meaningful information from the data that was entered by the inspector. So the first thing is, let's talk about the inspector. This person is not only inspecting these injection pens, but they're categorizing defects into 4 different areas. One, we're going to look for cosmetic defects. Secondly, we're going to look for minor defects. Third, major defects. And finally, critical defects. And you'll find that there's a chart for each one of those defect types to the left here. So when I click on one of these buttons to the left, you'll find that a chart shows up in the middle area. This is showing us a C chart of cosmetic defects. Now what's happening is every hour on the hour, this inspector is going to each one of the production lines and taking a sample of 100 products and then doing that visual inspection, then noting how many defects have occurred. Now when we look at this chart, you'll notice up top in this header, the white area, you'll see we're checking the titanium pen from medical line number 1, and these are indeed the cosmetic defects. If I wanted to look at the minor defects, I simply click this button here. And you can see that this chart, it's a little different from the cosmetic chart in that we've placed a report above. And in this report, you can see the number of defects. You can see the subgroup size. You can see the time and the date and other information. Now, you've got the real estate to be able to do that. And so some charts, you may want to put this report on there, and others, like this one, you may not want to. This is a major defects chart. And lastly, here's the critical defects chart. Now, when we look at this chart, this is a little different. You see, critical defects are just that. They are extraordinarily important to us because if we have too many critical defects in the 100 we inspect, then we have to put that lot on hold, or we have to inspect the entire lot, let's say. And so if we ever have any inspection where we have more than, say, 5.5 critical defects, then we want to alert a lot of people in the plant. In fact, what you're seeing here, this horizontal red line indicates for us a specification limit. So yes, InfinityQS does indeed have the ability to apply spec limits to attributes data. In this case, the spec limit is 5.5. Now, why would that be? Well, there's no such thing as half of a defect, but instead, if we found 5 critical defects, it wouldn't trigger an out-of-specification alarm. But if we found 6 critical defects, then there would be an alarm that would be created. So that's the way this operator might navigate around to different charts and graphs. I'll cover these other charts later. But some of the other things the operator may be doing is working with the toolbar buttons that you see down below. For example, if I were to begin an inspection sequence, I would just click the big green plus to add defects data. If I had the privilege to do so, and if I needed to, I could edit a subgroup of data. And by the way, once again, InfinityQS does allow you to comply with the FDA's requirements on electronic signatures. And if any edit ever occurs, we're going to identify who it was that edited the data. We can require reason for change codes and other items which will allow you to comply with the FDA's requirements. Now, another thing that may happen is this roving inspector is indeed roving. So if I were to walk over to a different medical line, this one's medical line number 1, but if I wanted to do that, I could click this Change Process button down in the toolbar. And when I do so, it's going to show me all the different production lines that these products are manufactured on. So if I click on medical line number 2, if you would, just note the average number of defects on this particular chart, which is 3.17. Now, when I switch to a different medical production line, you'll notice that not only does the data change, but you'll see that the average changes as well. Why is that? Well, because this medical production line has a different defect rate than compared with the previous production line. See, this is still the titanium pen. You look up top here in the header, you can see this is still the titanium pen, but a different production line. Now, the operator, the inspector, also has the ability to change over and look at data from a different product code. So I can come down here to this Change Pen button. When I do so, InfinityQS reveals to me all of the different pens that I may need to inspect. Now, this listing could be hundreds or thousands of items long. I only have 4 here, but you get the idea, is that I can switch to a different pen altogether, and InfinityQS automatically updates the chart to reveal to me the data specific not just to that medical line number 2, but to the newly selected blue pen as well. So another thing that's important for you to note here is that, and this is a huge differentiator for InfinityQS compared to other SPC competitors, is that one single project, that's what you're looking at here, is a project. This one project gives me the ability to sort, slice, dice data any way I want to, but also I can enter data for any of these production lines, and I can enter data for any of these different product codes. So with one single setup, we call it a project, you can do literally hundreds, thousands of different inspections for hundreds or thousands of different products. So that's the way the operator might interact with the software. The next thing I'd like to do is I'd like to talk about the actual data entry itself. So to begin data entry, all I have to do is click this button down below in the lower left-hand corner. Yeah, I can either click it or, you know what, there's a hide key here. You'll see the A has a horizontal line underneath it where it says Add Defects Data. So I just hit the A and that begins the data collection sequence. Now notice how nice and clean this window is. Double-sized fonts, great big buttons. This is ideal for that touchscreen environment where your user is walking around with a tablet computer. So I can select one of these predefined lot codes, or I can barcode scan this information in. And InfinityQS allows you to use any barcode equipment, any barcode scanning software of any type. Also, if you want to, if you're using touchscreen computers, then you can leverage the capabilities of our alphanumeric keypad. This gives you the ability to do away with keyboards and with cumbersome mice on the shop floor so that you can just use this capability to very easily enter data. So as an inspector, I'm going to go ahead and select my lot code that's unique to what I'm inspecting, and now here is the actual data entry window. Now, if you recall, we're actually checking for 4 different categories of defects: cosmetic, minor, major, and critical. And as the inspector goes through these 100 items and is checking them, he or she may find a defect here or there. In fact, let's say that this user found 2 major defects. When I click the down arrow, you'll see InfinityQS reveals to me all of those categories of defects. And let's say that the major defect I found was that the company name was missing on the pen. Let's say I found 1 cosmetic defect where the burn mark was in area A. And I keep looking and I find 2 more burn marks that are in area A. So I just put in 2 and then select that particular cosmetic defect. So I'm going to go ahead and save this to the database. And now InfinityQS is asking me to re-sign in. So this inspector, Ralph, he's got to re-sign. Even though Ralph has successfully signed in, Ralph is now being required to sign in once again. And this is another one of those things that InfinityQS allows you to easily do, that is easily comply with the 21 CFR Part 11. And that is, we can confirm, validate that Ralph is actually the guy who is entering the data. So Ralph puts in his password. The data is committed to the database, and all the charts and graphs update in real time. The moment this data is entered, it's wirelessly transported over to the database, and you, the administrator, or anybody else now has access to that data in real time. Now, when I look at this chart, this again happens to be the major defects chart. And if I click and hold on this most recent subgroup, you'll find that InfinityQS pulls up detailed information for that particular data entry. You can see here's Ralph. He's the guy who entered the data. In fact, all of the traceability elements are shown right here in this window. Also, you'll see statistics and so forth. You'll also see listings of defect codes down below. So Ralph, he finds it really easy to enter data. And again, here's this guy who's roving around your plant, and I may do data entry for a different pen or a different process. In fact, let's do that. Let's say that now Ralph, he's finished with medical line 1. He's going to go to medical line number 2 and perform some data entry. So when I click Change Process, we're going to pull up the medical line 2 data. And let's go look at our critical chart. You'll find that there's my spec at 5.5. And again, medical line 2 is running the exact same product, the titanium pin, as is being manufactured on medical line number 1. So I'm going to click the Add Defects Data. And this is a different lot code altogether. And I'm going to perform some data entry. So let's say that I found 2 defects that were major. There it is. And let's say that I found 6 critical defects. I'm going to save that to the database. Ralph is going to have to sign in. And if there's an alarm, you're going to know it. Here's a great example of how at the workstation where the alarm occurs, we're going to make absolutely certain that Ralph or whoever it is who entered the data, we're going to make absolutely certain that this person knows what's happened. Looking at this window, we can see that on medical line number 2, the titanium pin, we had a critical defect. Actually, we had 6 critical defects. And I'm going to click the OK button. But what we have here is one visual cue. Then the chart itself is a visual cue. Here's another chart. This is the critical chart where we are able to see that data that was just entered. But the moment that red window pops up, we're going to send an email out to anybody across the globe, anyone who needs to know about these critical defects. So we can also communicate with external applications. So if you want InfinityQS to pass information out to machine controllers or out to other applications, we can certainly do that as well. So you can affect closed loop control by gathering information from InfinityQS if you choose to. So that's how InfinityQS can indicate to a user that something unusual has happened. Now, we save that information to the database as well as emailing that information out. So let's stop here and let's go back over. Let's take a look at our cosmetic chart. Now, you'll notice that we plotted a 0 on this chart because we didn't find any cosmetic defects in the last inspection. Now, and what I'm going to do here is I'm going to go ahead and I'm going to switch between medical lines 2 and 1. Just by clicking the change button here. And if you will take a close look at the average value for the C chart, we'll see that 4.625 defects, cosmetic defects, on average were occurring for the titanium pin on line 2. If I select line 1, InfinityQS updates the chart, and you'll see that we have a higher defect rate here for line number 1. So that may be of interest to you, and certainly that's critical information. But switching between medical line 1 and medical line 2, that may be less than efficient. Instead, what I'd like to do is I want to know what those defects are, and I want to be able to compare all of them on one chart across all medical production lines. So let's do that. In fact, I've got here a Pareto chart that's created just for doing that type of comparison. So what we see here is all pin defects across all medical production lines. And we can see clearly medical line number 1 has more defects and has a higher defect rate than medical line number 2. And if I wanted to know, well, what are the defects that we're seeing for each one of those medical production lines? So what we've got the ability to do is very easily sort, slice, and dice the data. And we call that the processing option within InfinityQS. So in this option, you'll see that there's a sort category. Right now, we're looking at the defects sorted by process. Instead, what I'd like to do is I'd like to see the data broken out by test, that is by category. And so clearly we can see cosmetic defects is leading the race in terms of the max number of defects. Led closely by major, minor, and then lastly critical. We got 67 criticals. So again, this is interesting information, but you know what? I need more information. I want to know by medical production line what these defects are. So, easy enough. I can go back to my processing options. And here I can tell InfinityQS to first categorize by process. And then there's a secondary sort category, a minor category. And in here I say, show me those categories of defects for each medical production line. When I click finish, there's your result. So now I can see, yes, I do have 324 defects on medical line number 1, and those defects are the ones found in blue. So the blue bars roll up to the yellow. This is a great example of what we call, at InfinityQS, we call this a multi-level Pareto chart. It's a Pareto within a Pareto. And so this gives us the ability to look across production lines. But the next thing I may want to do is I may want to say, well, okay, now that I know which production lines are creating the most defects, and I know what those defects are, but the next thing I may want to do is understand, well, which product codes, which pins are creating the most defects? That's just another sort. So we right-click, go back to our processing options. Instead of sorting by the test as a minor category, let's sort by part. When I click the Finish button, InfinityQS does that for you. So we have answered the questions. Where are our most prevalent defects? Is it medical line 1 or 2? We're able to answer in this specific Pareto, well, which production product is it? Is it the titanium pin or the blue pin? Well, clearly, it's the titanium pin that has the most defects. So in this case, it's not process specific. The defects are product specific. So we know the titanium pin is giving us the most defects. We know it's medical line 1 we need to focus on first. And so all this information is very easily accessible through the InfinityQS software. And you'll notice I've done all this sorting, slicing, and dicing on this one single chart. So again, you can put any data on any chart, sort it, slice it, dice it in any way that you choose so that you can get answers to the questions that you need. Let's take it a step further. Let's say that we want to look at all defect codes. Here's a great way of doing that. This Pareto chart is showing us all defects, everything in the entire database. All cosmetic, all critical, major, minor defects across all production lines, across all product codes. So this is everything on one chart once again. Only this time, we've sorted it by defect type. But this information may not be enough for me. In fact, I look at this and I might say to myself, well, you know what? I need more than the frequency of defects. I need to know the time involved with reworking these products. And cracked or broken tabs, well, 30 of those, well, it doesn't really tell me about cost. And so InfinityQS does have the ability to create weighted Pareto charts. And so what we've done here is we've associated to each one of these defect codes the amount of time necessary to rework that particular defect. And so with InfinityQS, just once again, right-click, go to your processing options. And in here, there's some general options we can play with. Right now, we're processing the data as default. That's just the count, the frequency of defects. I'm going to choose weighted. And this is going to take the actual frequency, multiply it by a factor value, and the result is going to be the number of hours of rework that we have applied for each one of these different defect codes. So now we can see cracked or broken tabs. Yes, I had a bunch of those, but we've spent 75 hours in the last X time frame reworking those defects. And if I pull this window back, I can see a report of this data. So this indicates to me what the factor values are, how many pieces have been inspected, process capability indices and such. And you can see here the factor values are all called out. So it's simple for InfinityQS to identify from a defect level, well, how many defects we have and the amount of time we're spending reworking things. But let's take it to the next step. Let's say that we're interested in understanding, well, which part numbers have the most rework time associated with them. So by going in here to our processing options, we can go and tell InfinityQS to show us, say the major category, let's make that the part first. And then the minor category, let's make that defect code. And the result here is that we can see how much time has been applied towards reworking the titanium pins. That's 201.85 hours. And we know the primary reasons for the rework. And by scrolling down, I'm able to see which the amount of time that's been applied towards the blue pin as well. So we're just going through and asking questions, and InfinityQS makes it very simple to answer those questions. Another question you might ask is, how many defects have occurred by lot code? And you'll find there's a chart specifically identified for that question. And here we go. So lot code 1245 had 81 defects. And that's what the defects were. Scrolling down, you'll be able to see all the other lot codes. You can see those calling up in yellow. So it's really simple to answer those questions. And you may ask the question, well, which inspector is it that's catching all these defects? And here's a Pareto chart for that. So what you've seen here is a very, very simple way of performing data entry. And it's really, the operators, the inspectors love InfinityQS because of its simplicity. At the same time, you get the information you need. You get the questions answered that you need to get answered. And you can even do other things with InfinityQS. We can also not only create charts and graphs of data, but as you've seen, we can create charts that are actually embedded photos, pictures of your own products. And if you want to be able to pull up websites that are filled with information, here's a great way of doing it. Here's a chart that is a website. This is a live website, and it's an InfinityQS website for understanding better what defects per million opportunities charts are. So this detailed technical information may be useful to you. And in fact, that brings me to another issue, and that is that it's not just that InfinityQS supports attributes control charts, C charts, U charts, P charts, and MP charts, but we also support DPMO charts. And here's a great example of that. This DPMO chart I'm showing you here is showing multiple product codes all on the same chart. The scaling now is the defects per million opportunities. So we can see here for across the blue pen as well as the titanium pen for medical line number 1, we can see that the defects per million opportunities equates to 16,538. So with that standardized scale, we can now place all of our product codes on this one chart and compare and contrast them against one another. Also, we can see that this is data rolled up across product codes for this one medical production line. So in this presentation, we've focused on how easy it is for InfinityQS to allow you to enter attributes data. And it's not just that it's easy to enter data, it's also very simple to analyze that data. So if you want to be able to create defects per million opportunities charts, if you want to evaluate defect codes, any way that you want to evaluate them, InfinityQS is going to allow you to do so. It's very simple to make these charts and graphs, and they're incredibly informational about what's happening in your processes. And not only that, but we also give you the ability to very simply and very easily comply with stringent requirements from the FDA. In terms of traceability and validation, InfinityQS allows our customers to very easily manage those requirements. So the bottom line is that InfinityQS has the flexibility and the functionality that you need in order to properly manage your processes and extract meaningful information from the data so that you can become more effective, more efficient, lower your costs, and improve your overall quality.